Hey guys, and welcome to a new video in this C++ tutorial. In this video we're going to talk more about object-oriented program and specific talk about polymorphism. So first of all we're going to talk about have a short recap of what object-oriented programming is and what we've talked about in the previous two videos. So object-oriented programming is about creating objects that can contain both data and functions, and when we're operating with data and functions inside of classes, we call them attributes and methods, which is the member functions and the member data of that class. So there's some different kind of advantages over normal programming when we're using object-oriented programming in modern programming. So it's both faster and also easier to execute and develop, and it provides a clear structure of the program and a much better overview because it is possible to divide our program into smaller classes or just smaller subsets. So it just makes our program more structural, and just you will get a much better overview if you're using object-oriented programming compared to just normal programming where we're just writing everything down in one file of code. So it also helps us not repeating the code again. So we can just create one class and then we can just create multiple objects of that class instead of we have to copy paste and repeat the same code again when we need to initialize a new object. And it also makes the code easier to maintain, modify, and also debug, and it makes it possible to create full usable, reusable applications with less code and development time. So once we have already created a class, we can use that class in other applications or programs as well where we need the same class. So it's easier. It's easier to just take the class you have already implemented and make it portable to another application. So down here we have this figure here where we already have talked about classes and how we can create objects of a class, and we also talked about attributes and methods of a class in the first video about object-oriented programming. And then we went over a bit encapsulation and abstraction, what we have when we encapsulate our data and our functions when we're talking about object-oriented programming. And then we talked about inheritance in the last video where we can inherit the attributes and the method from a superclass, and we can then derive derived methods and attributes, so we can use that in subclasses as well. So in this video here we're talking about polymorphism and why it is important in object-oriented programming and what it can be used for. So polymorphism is the word means that it just has many forms. So when we're using polymorphism we want to have some instance that could have many different kind of forms. So a person, for example, if we take this example here, a person can have different characteristics, and a person could be a father, a husband, and an employee at the same time. So the person object here could have many different kind of forms, and we're using polymorphism if we have some functions we want to do something with. So on the graph down here we can see that we have this polymorphism here, which has two sub areas here where we have the compile time polymorphism and then the runtime polymorphism. So the compile time is the polymorphism when we compile a program, and then the runtime polymorphism is when our program has been compiled and the program runs, then this is polymorphism at runtime. So if we go up here to the compile time polymorphism here, we have operator overloading and function overloading. So if we want to overload some functions or some operators, we need to do it at compile time, where if we're using virtual functions, we can do it at runtime instead of compile time. So if we're talking about these operator and function overloading first, then we have this function overloading here, which is just so we can have multiple functions with the same name, but they have different parameters. So it can either be a various a number of arguments, or it could be different types, data types of the arguments. So if we see the example down here, we have a function here that is called display, and then the first function here takes two parameters here with an integer and a double. So it takes two parameters with different data types as well, and then we can overload the function down here. So we have the same function with a function with the same name but with different number of arguments. So in this case here we have this double parameter here, and we can actually overload again where we only have these two only takes one argument, but they have different data types. So this is how we can overload our functions if we want to do some calculation. For example, if we want to pass an integer to one function, and also if we want to be able to pass a double or a float value to the same function and do some different kind of calculations, then it's possible to overload our function and do different kind of stuff instead of coming up with a new name if the function actually like does the same, but it just takes like an arbitrary number of parameters or another like data type. So we can also like have this operator overloading here, where we can like kind of like make our own operator, like or overload the already like existing operators in C++. So an example here, like to give your like intuitive introduction to it, like we can like tell the program to like how to add two persons objects together. Like if we create two instances of a person class, for example, we'll have two person objects. And if we just try to like add those two with the plus operator, for example, like the program doesn't know how to like add these two objects here. So then we can go into like our code and also and actually like overload our operator. So in this case here, we will have a class here, and then we have a keyword here for the operator. And then we have the operator symbol here in here, where it's like it is the like the operator that we want to overload. So let's say we want to like add these two person objects together, then we will have like the class name here would be a person, and then the operator here would be the plus sign, and then the argument list could be another person class, and then we can actually like tell the program here in the function body like how to add these two persons together. And this is like how we can overload our operators, and like we can overload all the operators there is in C++. So it's really efficient, and also when we're creating our own classes and working with object-oriented programming, like it's very good, and also like a pretty nice feature that we can actually like overload our operators and do with it what we want to. So we can also like have these virtual functions here. Like we're going to have examples in code as well later in the video, so you can see like how to actually like implement these things in C++ and work with it. So virtual functions is like we have a member function which is declared within a base class. So let's say we have a base class here called shape, which I'm going to show you as well in code. So we have this shape class here which has a member function here called draw, and then we can declare this draw function here virtual, which means that we can actually like override it in our derived classes. So for example, if we want to draw a line or draw a triangle, then we can like override this draw method here that is declared in the base class here with the function that we want to like, if we want to like draw a line here, it wouldn't be the same draw function as if we want to draw a triangle or rectangle, for example. So we then override it by each derived class here. And we can also like have pure virtual function, which is kind of the same, but when we declare our functions, like our virtual functions, pure as well, then we need like for every time we're inheriting from one class, we have to like make an overloading of that function. So if we, for example, like had a circle here that is deriving from or like inheriting from the shape class here, and we didn't override this draw function here, we will just run into a compile or like runtime error, because we didn't like specify what this draw function had to do. And we declared it up here in our base class as a pure virtual function, which means that we need to override it in our derived classes for our program to run. So let's jump into Sublime Text here and see some different kind of examples of like how to use these kind of overloaders and how we can use polymorphism in C++. So we're now into Sublime Text here, and I'm going to show you the different kind of examples like how we can implement and work around with polymorphism in C++. So we're going to take the last example as where we implemented the classes with the shapes and also like the rectangle and triangle from the last video, where we talked about inheritance and how we can inherit from that superclass here, which is the shape class. So the first thing I'm going to show you is like how we can override our functions. So the first example here, this is just like to show you guys like these functions doesn't have any purpose when we are overloading them. So first of all, we have this virtual function here of the area here, so we can derive it and also like override it in our own derived classes. And then we have another function here which has the same name here, area, but this one takes an integer as parameter here, x, and then it just returns the x plus 1 here. So this is like a function overload. And we have the same down here with the area, which just takes like two parameters in this case here, and it just takes two strings and print those two strings out. So these functions doesn't have any doesn't make any sense, but it's just to like show you guys like how we can override functions in C++ and also use this virtual keyword here. So in this case here we actually like have it at virtual because we can, if we set this function here virtual int area equal to 0, then we declare it as a pure virtual function, which means that we have to like override the function for each class that is deriving or like inheriting from this shape superclass here. So if we go down here to the rectangle class again, we can see that we are overriding the area function here in the rectangle class, and we're also overriding here in the triangle class here. So if we go down here and just output it and run our program here, we can see that we get the same result as in the last video, where we have this rectangle area here, which is 10 times 7 and 10 times 5 here, in this case down here, for the triangle. So this will be the area of the first triangle, and then we also dated with unique pointers, like how we can have unique pointers pointing to the objects that we're creating of our rectangle and the triangle class. So we can also like have this operator overloading if we, for example, like had two rectangles and we could overload like the rectangle here. So we would specify the rectangle class and then the operator, and then the operator we want to overload and then pass in another like rectangle, or we can actually like have a shape class as a parameter to that function, like operator overloading. And then we could like specify like how we want to add a rectangle and a shape, or we want to like add a rectangle and a triangle, for example. So if we didn't overload our operators, like the C++ wouldn't know like how we can add a rectangle and triangle. So we have to specify that ourselves inside of our operator overloader. So the most important thing from this video here is that we should know like how we can overload our functions, and also how we can use pure virtual functions, because sometimes it's really good to like declare this virtual and then our function and then equal to 0, so we declare it as a pure virtual function. Because let's say we for example have these different kind of shapes here, and we want to make sure that we doesn't like miss calculating the area of some functions, or if we made a computer game and stuff like that, then it could be like maybe like different kind of characters that had a function called attack, or like get health or something like that. Then we will make sure to override all of these functions for each class that we derive from our superclass. So this is like a good coding approach to take if we're like using a lot of different kind of functions that does the same as its superclass, and then declare it as a pure virtual function, and then override that function in the derived classes as well. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification under the video, and also like the content if you want more of it in the future. If you want to do something with the things you learn here in C++ in this tutorial, I'm also doing a computer vision tutorial with OpenCV and an algorithm and data structure tutorial and both of the tutorials are in C++. So if you want to like use some of this for some practical approaches, you can go check one of those tutorials out. I'll link to one of them up here, or else I'll just see you in the next video, guys. Bye for now.